Our final exercise is regarding the dollar addresses. We're gonna click down here next to club members. This is gonna add a new Excel sheet. So we're gonna also double click on this sheet 1 and rename it to be to have a name tables. And then let's insert exactly to C2 numbers 1 and D2 numbers 2, and then let's select these two together. And now when we select numbers like this and click and drag and copy, then what it does is it kind of detects what's going on between 1 and 2 and multiplies this system further and further until we reach 10. We'll do the same thing into B3 and B4. And now let's select them and let's copy them until 10. And the third thing, we're going to come back to those dollar addresses now, and the first thing we're going to do is we're going to create a multiplication table, just as a simple introduction. Let's write something like this: equals. Let's take from the upper cell before, so equals C2 multiplied with B3. We multiply these two together, and now, since we want to copy this formula to the entire table, we have to use dollar addresses again. And let's think of it. C2, do we want it to move up and down? Do we want it to move left and right? We do want it to move left and right, but it can't come down when we copy the formula down. Thus, we have to fix the second row, which is F4, until we have $2. Then we take B3 and consider this. B3 will have to move up and down, but it can't move left and right with us. So what we will do is we will fix, it can't move left and right, so it has to be fixed, it has to have B fixed. So it's $B3. And here it is. This is actually something we had in the discounting problem already, with a table that has a upper header, a header up there, we fix the row number. And then if it has a header on the left side, we fix the column number and the column sign. And now we copy it. Let's copy it this way this time. We copy the entire column and then multiply it for the entire table. And here it is. For instance, 7 times 8 is 56. Everything works perfectly. The upper header hasn't moved down, it has moved to the side. The leftmost header has moved down, it hasn't moved to the side, and it works perfectly. Okay, so a multiplication table all in one step. Okay, let's move on. Now, something that hasn't even been touched often is when we consider. Let's at first go back to the decreasing marginal utility. Here we see that, let's say, our number of ice creams or grams of ice cream is on the x-axis, and what we're calculating on y-axis is how much utility or pleasure or whatever it is, fullness of our stomach we get from that food. And thus we can say that y, which is our utility, depends on x, which is the amount consumed. Okay, so that's how it works. Now, often in business we have functions like, I'm just going to write it out for a second, where, for instance, z equals, let's say, x times y. So we have two variables, x and y both, and z, the third one, depends on them. But let's bring another example just in a second. What we want to do, we have a three-dimensional space. Let's say that we look at one corner of our room at home, and we think that on the floor the two corners going from the corner are x and y, and the direction going up is called z. So our room is three-dimensional. Now let's graph it out first. So let's use different numbers now. -5, -4, and let's copy it. Actually, we want to do it from -5 to +5, but since there's a 0 in the middle, we have to make a table that's a bit bigger than the previous one was. Okay, same for another direction, -5, -4, and up to +5. And now let's create a formula where we use now, this is the x value as it is the x-axis, this is the y value as it is the y-axis, and now we calculate z, which is, as we said, z equals, let's say, from x and y something. Let's say that our function is equals, now let's take x to the power of 2. For that we have to hold down Alt key and click on 94, and we had the roof sign, and now click on number 2. So it's equals C14 to the power 2. Okay, and let's say minus, and now let's subtract the y value. Minus B15 to the power 2. Okay, so it's basically, it is x squared minus y squared. Let me just write it out. Z equals x squared minus y squared. That's what we're doing. And we have to put the dollar signs. The dollar signs we will put in the same way. We will take the x, which is C14. It cannot move up and down, so we will fix the 14th row. It has to move left and right. We take B15, which is y-axis. It cannot move left and right, but it has to move up and down, so we will put the dollars before $B15. And now we have this x squared minus y squared nicely with dollar signs as well. And we will copy it. Okay, and now these values here are all z values. So for instance, we could make them bold so that the contents of the table itself will stick out. Okay, now, or maybe it's better the other way around. We will make the headers bold. Okay, and now, since these here are z values, actually Microsoft Excel has what is called a surface chart. So all we need to do is we select the numbers themselves. We click on insert, and now column chart was, for instance, for numbers like costs of a room or areas where we had single numbers. Line chart was when we had stocks where some kind of a set of lines was were going up and down, racing each other. Scatter graph was where we had pairs of coordinates, like for instance the decreasing marginal utility function. And now, finally, let's take some charts that are less used, and for instance, let's take other charts and let's select surface. And here you see now the origin of coordinate axis. The origin of coordinate axis is is in the corner, and on the floor we have here we have x-axis, and here we have y-axis, and z-axis is up here, and it depends on x and y. Here we have just a mathematical function. It is a beautiful function because it looks like a saddle, but it's just abstract for us anyways. But in economic situations, we can, for instance, take x and y to be two stocks, and then we can combine a portfolio from them, and then the z-axis can be, for instance, the risk of the stock portfolio. So once again, we're right now like learning some kind of building blocks for our Excel models and Excel worksheets, and we'll be using them in more and more difficult situations later on. And of course, once again, the dollar signs are important here. We fixed it just nice the way we've done it all day long today. And now, the last case. Let's take, for instance, x times y. So z equals x times y. Let's see what this is. But let's do it a bit differently. Let's do again minus 4, minus 5, minus 4. Let's copy these. Then let's do it for the other dimension as well. Minus 5, minus 4. Let's copy these. And now let's give a name. Let's put x in here, and let's put y in here. And now let's give a name just the way we've done. Let's select these, and let's click formulas, and create from selection. Okay, and now since x, the name, is really in the right column, it's the correct name it tries to give, we'll click OK. And then we'll select y, which is in the bottom, formulas, create from selection, and we're lucky today, all the things it's guessed have been right. Y is in the bottom, let's click OK. And now it turns out that we can do it with names as well. So we only have to write equals x times y. And it takes from the blocks, it takes out from the blocks correctly. And then we copy it to one side, take the block and copy it to the other side. Okay, here it is. And now we select the data. After copying it, we select the data, and we give the command insert, other charts, surface chart. And here you see such a kind of a sheet that has been deformed is in front of us. So this is how our third week has ended.